Hey everybody, in this video we are going to go over what a net of a three-dimensional shape is, as well as what is the surface area of the shape. So when we talk about the surface area of an object, we are talking about the entire amount of surface that a three-dimensional object has. So for example, I have this whiteboard eraser and it's a three-dimensional shape. It's technically, we would say, a rectangular prism, or we could probably say it's like two rectangular prisms put together. Like the eraser part is its own rectangular prism, and then the actual plastic handle is its own rectangular prism. So the surface area is the area of all of the outside surface of this eraser, and for any object it's the outside surface. So like if I was to paint this eraser like a different color, the amount of paint that I would need to paint like the outside of it, or especially like the plastic part, that I would need to know like how much surface area there is, so I know exactly how much paint to use. So the way we calculate surface area is essentially we find the area of all the different surfaces. So I would find the area of this surface, of this surface, of this surface, of this surface, and so forth. So a lot of times what's helpful when we look at surface area is we kind of break apart our shape into what's called its net. So essentially it's taking a three-dimensional figure and kind of, if we like were to cut it along the seams and kind of unfold it, what it would look like as a flat two-dimensional shape. So nets are important. This is when we take a 3D shape and break it down. So a 3D shape broken down to a two-dimensional figure, to a 2D figure. So taking a three-dimensional shape and breaking it down into a two-dimensional figure. So the first kind of three-dimensional shapes we're going to talk about are prisms. We're going to look at rectangular prisms, triangular prisms, and a cylinder. We also have trapezoidal prisms. I'm not going to draw the net of it here because they essentially look very similar to the ones that I'm about to draw, but instead of the base shape being a circle or a triangle or a rectangle, it'll just be a trapezoid. So with the prism, we always have our base shape. So if I have a rectangular prism, my base shape is either a rectangle or a square. And I have two of them. And then all of the sides are going to be parallelograms. And typically in rectangular prisms, all of the sides, the parallelograms are also rectangles. So we have four sides in a rectangular prism. And so I'm kind of breaking it down to showing you, if I unfolded those four sides, what they look like. And then kind of on either end, we have our base shape. So this could either be a rectangle or a square when we have a rectangular prism. In a triangular prism, our base shape is a triangle, and all of our sides are also parallelograms, and they are also typically rectangles. But because a triangle only has three sides, then in our triangular prism, if you think about like a tent or one of those Toblerone candy wrapper boxes, there's only three sides to it, but we have our two base shapes. So these are what the nets look like for a rectangular and a triangular prism. We call this part here with all of the rectangular sides, or the parallelogram sides, we call this part, this is called the lateral surface area. Because it is the surface area of the lateral part of the shape, or what we think about as like the sides of the shape. So if we want to find the total surface area of either a rectangular or triangular prism, essentially what we do is we find the area of each of what are called the faces of the shape, and we add up all of those areas together. So like in this particular triangular prism, the faces are the two triangles and then the three rectangular sides. In a cube or in a rectangular prism, we have our two either square or rectangle base shapes, and then also our rectangular sides. So a face is a flat surface that makes up part of a 3D shape. Flat surface that makes up part of 3D shape. So this is kind of what these two prisms look like if we broke them down into a two-dimensional figure. And when you're finding the surface area, essentially, as I've mentioned before, all you're going to do is find the area of each of these different two-dimensional shapes. So we have our length and our width for each of our bases, right? So to find the area of these bases, we would just do length times width. And then because the lateral surface area of a rectangular prism is also rectangles, we're just going to do length times width. But in this case, the length is essentially the height of the prism. So how tall or how long, if the prism's kind of sitting on its side, how long or tall the prism is, that's going to be this measurement here. So all of this is like the height. And all of this is that width of the base. So to find the area of each of these rectangles, you'll take the height of the prism times like that same width of the base here. And it'll be the same area 4 times. So you can, like, when you're finding the total surface area, you can multiply it by 4 in the long run, or you could just add them up 4 times together. With a triangle, it's a triangular prism. It's similar, except in a triangle, we have different parts, right? We have our base of our triangle, and then we have the height of the triangle as well. I'm just going to kind of draw an arrow and put a lowercase h for height. I'll model it over here better. Here's the height. And so what that means for the area of the two triangles is we do our area formula, 1/2 base times height, to find the area of the two triangles, or to find the area of one triangle, and we can multiply it by 2 when we're finding the surface area, because it should be the same area for both of these triangles. My triangles don't look exactly the same, but the area will be the same. And then for the rectangular sides, this again is like that height of the prism, like how tall the prism is or how long the prism is if it's turned on its side. And then all of these measurements here, it's going to be the base, the same measurement as the base of the triangle. It's the same measurement as the base of the triangle. So to find the area of each of these sides, you'll take the height of the prism times the base of the triangle to find the area for each of these sides. So the total surface area is adding up the area of these 3 rectangles, which should all be the same, and the area of these 2 triangles, which these 2 triangles should be the same. The last kind of prism, or something that's similar to a prism that we're going to look at, is a cylinder. So a cylinder, its base shape, so its top and its bottom are both rectangles. And the lateral surface area, kind of that side or that edge, is it's essentially one giant rectangle. If you think about like a toilet paper roll or a paper towel roll, if you were to cut that and kind of flatten it out, it would look just like a giant rectangle. So what that means in terms of finding the surface area is to find the surface area of the top and bottom shapes, the circles, we're going to use our regular area formula. We're going to need the radius and pi, really, to just find the area of these 2 bases. They should be the same, right? The area of these 2 circles should be the same because they're just like the top and bottom, the base shapes of the cylinder. But to find the area of this rectangle, this is going to be the height of the cylinder, like how tall the cylinder is. But this part here, I'm going to use a different color to kind of show you. This part here is wrapped around this circle. So I want you to take a minute and I want you to think about, what does that mean about the measurement of this part of the cylinder? It should, if it's the same measurement as what kind of looks like the perimeter here of the circle, with a circle, we call that what? Take a moment. It's the circumference. I'm just going to abbreviate it, circumference. So that measurement here is the circumference of a circle. So when we find the surface area of a cylinder, when we find the area of this particular rectangle, we're just going to take, since it's a rectangle, we're going to do length times width, but you could think about the width of our rectangle is the circumference. So 2 pi r times the height. I'm going to do a capital H. Okay, so when we find the area, if we're trying to find the total surface area of a cylinder, this is how we find that lateral surface area, that kind of like side parts of a cylinder, and then we can add up the 2 areas of the circles to find the total surface area of a cylinder. So surface area is essentially just the area of the surface of a shape. That sounds kind of obvious, but the area of a shape's surface. So I'm just going to put all the faces. So all the faces of a shape. And all we do to find surface area is add the area, or areas, I guess I should say, of the faces. So this video is not going to go into depth about like calculating the surface area of a particular object, because we've done many examples of how we find the area of two-dimensional figures like squares and rectangles and triangles and circles. All you really have to do with surface area is find individual areas of multiple shapes, almost like a composite figure. Nets are essentially kind of like a composite figure, but they're a composite figure of a 3D shape flattened. You're just going to find the area for each individual shape and just add it up. And if the same area is repetitive, you can like multiply it to get, you know, what the area for just these couple shapes are, or just the two bases are, and so forth. So in the next video, I'm going to break down the nets of a pyramid. It will be a much shorter video. You might need to refer to your area formulas for area of triangle, rectangle, circle, because if you don't have kind of them already ingrained in your head, because you will need them when you find the surface area of objects.